Look around you. The Earth feels impossibly huge. Oceans you could sail for weeks, mountains that take days to climb. But our planet is just a tiny speck, and the universe contains things so unimaginably vast that they make the Earth look like a single grain of sand on an endless beach. So today, we're going on a journey. We're going to start small and then zoom out, step by step, and at every step, the thing we find will completely dwarf the one before it. Bigger and bigger and bigger still, until we finally arrive at the single largest thing in the entire universe. And I promise you, by the end, your brain is going to hurt. Let's begin. Let's start with the biggest thing in our everyday sky, the sun. We all know it's big, but big doesn't even begin to cover it. If the Earth were the size of a small marble, the sun would be a beach ball over a meter wide on the other side of the room. In fact, you could fit around 1,300,000 Earths inside the sun, with room to spare. It is so large that light, the fastest thing in existence, takes about 14 seconds just to travel all the way around it. And yet, and this is the important part, on the scale of the universe, our enormous sun is utterly, laughably tiny. It's just an ordinary, fairly small star. So let's keep zooming out, because out there among the stars, there are monsters. The largest star we have ever found is called Stephenson 2-18, a swollen red hypergiant. Its radius is around 2,150 times larger than our sun. To picture that, imagine we swapped our sun for this giant. It wouldn't just swallow Mercury, Venus, and Earth. It would engulf Mars and Jupiter and stretch all the way out past the orbit of Saturn. You could pour about 10 billion of our suns inside it. And remember, light circled our sun in 14 seconds? To travel around Stephenson 2-18, that same light would need around 9 hours. It is one of the most colossal single objects in existence, and we are still only just getting started. But here's the thing. Even the biggest star is just a single point of light next to what comes next, an entire galaxy. Our home, the Milky Way, is a vast spinning city of stars. It contains somewhere between 100 and 400 billion stars, and that monstrous hypergiant we just met? In the Milky Way, it's nothing more than one tiny, glowing dot among hundreds of billions. Our galaxy is so wide that light, which crossed that giant star in 9 hours, would take around 100,000 years to cross from one side of the Milky Way to the other. We've gone from a marble to a star that swallows Saturn to a dot in a galaxy. And we are nowhere near the top. And our Milky Way, for all its hundreds of billions of stars, is actually a fairly average-sized galaxy. The largest galaxies are almost beyond belief. One of the biggest ever found is a galaxy called Alcyoneus. While our Milky Way is around 100,000 light-years across, Alcyoneus stretches an astonishing 16 million light-years from end to end. That makes it more than 100 times wider than our entire galaxy. If the Milky Way were the size of a coin, Alcyoneus would be the size of a large room. Our whole galaxy, all 400 billion stars, our sun, our Earth, you and everyone you've ever known, would be just a tiny smudge inside this single, monstrous object. And still, we keep zooming out. Now things start to get truly mind-bending, because galaxies don't drift through space alone. Gravity pulls them together into groups called galaxy clusters, collections of hundreds, or even thousands, of galaxies, all bound together. And those clusters? They gather into even bigger collections called superclusters. Our own galaxy belongs to a gigantic supercluster named Laniakea. It contains around 100,000 galaxies, and it spans over 500 million light-years. Picture that for a moment. 100,000 entire galaxies, each with hundreds of billions of stars, all flowing together through space as one enormous connected structure. And our entire Milky Way is just one tiny thread near the very edge of it. So let's pull back as far as we possibly can and look at the whole universe at once. And when we do, something incredible appears. The galaxies, clusters, and superclusters are not scattered randomly. Instead, they're strung together into vast glowing threads and sheets, wrapped around enormous empty bubbles, like a tangled cosmic spiderweb, or the soap suds in a kitchen sink. Scientists call it the cosmic web. The bright threads are where all the galaxies live, and the dark bubbles between them are colossal, almost completely empty regions called voids, some of them hundreds of millions of light years across, containing almost nothing at all. The entire universe, at the largest scale, has a structure, and that structure leads us, finally, to the biggest single thing we've ever found. It has a wonderfully dramatic name, the Hercules, Corona Borealis Great Wall. It is a single, colossal thread of the cosmic web, a wall made of galaxies stretched across space on a scale that is almost impossible to put into words. From end to end, it measures around 10 billion light years. Some scientists think it could be even larger, perhaps 15 billion. Let that sink in. Light itself, traveling since almost the beginning of the universe, would still not have made it across this single structure. It is so enormous that it actually troubles physicists, because our theories say the universe shouldn't be able to build anything quite this big. Some even argue it might be a trick of the data. But if it's real, the Hercules, Corona Borealis Great Wall, is the largest known thing in all of existence. But there is one last thing, the biggest of all, in a way, and it's the strangest. It's the entire observable universe itself. This is the total bubble of space we are actually able to see, and it stretches an incredible 93 billion light-years across. Now here's the puzzle. The universe is only about 13.8 billion years old. So how can we see things farther away than light could have traveled in that time? The answer is that space itself has been stretching and expanding ever since the beginning, carrying those distant objects far away from us. And this bubble is only the part we can see. Beyond its edge, the universe almost certainly continues, possibly forever, infinitely large. We can never see it, and we may never know how big the whole thing truly is. So, what's the largest thing in the universe? We traveled from a tiny marble Earth to a sun that holds 1,000,000 Earths, to a star that swallows Saturn, to a galaxy of billions of stars, to galaxies and clusters and superclusters, all the way to a wall of galaxies 10 billion light-years long, and finally, to the edge of everything we can possibly see. And through all of it, one feeling grows and grows, just how astonishingly, impossibly small we are. And yet, here's the beautiful part. We are the tiny specks who looked up, did the maths, and figured all of this out. We are the part of the universe that became big enough, on the inside, to understand just how vast it really is. If that gave you chills, hit like and subscribe. There's a new mystery every week. And I'll see you in the next one.